Hello, one and all. Let's see. Fish PowerPoint. So I spent my day today painting a house and doing some construction work for my biological father. So it turns out that I didn't get to this until later on today. I apologize. The good news is this is your last lecture, and tomorrow during your class, your regularly scheduled class, in lieu of giving you more content, I will just have question and answer sessions for your exam next week. Finally, a reminder that if you want to write hypothetical questions for your exam, please have those to me on Friday. That'll be December 11th. And I'll have office hours that day, I guess. And yeah, but please send me questions if you think that you're going to have them ready for the exam next Monday. I'll answer questions about the exam both tomorrow during our regular scheduled class time, and then again on Friday, should you have any questions. And it's not like I'm going to suddenly vanish this weekend. So hypothetically, you could ask me questions this weekend as well. I just might not be so reliable because I'm Saturday, I'm hanging out with some friends, alas. All right, fish. There's a bunch of fish. There are at least 35,000 species of described species of fish, and you can bet there are a lot more living on the bottom of the ocean we don't know about. They're the most taxonomically diverse group of vertebrates, and we again, we have no idea how many real species there are, and presumably there are vast regions of the ocean that we haven't explored, and we probably have the terrestrial vertebrates better vetted than the marine vertebrates, so we should expect that hegemony, that overabundance of species in fishes, especially ray finned fishes, to be very, very high. So ray finned fishes have like tiny little rays that extend through their fins. Then that would be most of the fish that you're familiar with, like seahorses or cichlids or bass or pike, or pretty much anything you can imagine. Specialty fishes that are not ray fin fishes include lobe fin fishes, which are coelacanths, and lungfish, which famously can live in dry rivers and make mucus cocoons. They're really strange. Something like a lobefish was the evolutionary precursor to all terrestrial tetrapods, which include you and me. So hooray for the lobe-fin fishes, but reality is there's only about 8 species. There's somewhere between 6 and 20 species, but I think it's 8 or 12 on planet Earth. There used to be 2 species in South America, 2 species in Africa, 2 species in Australia, but they might have added new species to that over the past 12 years since I last paid attention. Anyway, lobe-fin fishes gave rise to tetrapods like you and me, but the remnants of that radiation that are still in the ocean or in lakes and rivers, not that abundant. Cartilaginous fishes include rays, skates, and sharks, and although they are very ancient and successful in what they do, they're not that speciose. So, alas, most fish are not lobe-fin fishes, which there are 6 species of, and most fish are not cartilaginous fishes, although they're quite cool. We're not going to talk about them much today, but they are quite neat and should, deserve their own many lectures to describe their amazing biology, but I don't have time today, so sorry. Sharks get enough airtime on television. All right, fish, no joke, occupy diverse aquatic environments, both freshwater, lakes, streams, ponds, mud pools, hypersaline conditions, super salty, the abyssal pelagic where light never lands, kelp forests and coral reefs and everything in between. There are fish that never see shore in their lives. There are fish that never see light in their lives. And, they live in incredibly diverse habitats. Some incredibly impressive fish also have reasonably complex terrestrial lifestyles. So although they are reliant on water to respire and reproduce, they might skip along in the mud or be able to persist in muddy environments on shorelines or underneath rocks. And so, although fish are reliant on water, we should marvel at the fact that some of them are not that reliant on water, like the mucus cocoons that some lobe-fin fishes create when their rivers go dry can enable them to survive without water, basically in a mucus cocoon in the ground for months and or possibly years if they're large specimens. So fish do amazingly well without water when in some special cases. Okay, so sociality in fish, incredibly uncommon. So many fish aggregate, almost all fish aggregate. Aggregations in this case, which does not have a close parentheses, just means that they converge on a shared resource. So that could be something like we'll get into examples in just a second. They're like, they don't really like each other. They're not helping each other. They're not gaining a lot of social information. They don't love each other, but they are aggregating because they need something just like other individuals of their species or other species, and so they tend to be clumped in the environment. Shoals are loose aggregations that are in the same general vicinity. The individuals want to be near fellow members of their species or closely related species, and they make groups, but they're not like highly directed, coordinated groups like sardines or something like that in the ocean, right? So shoals are loose aggregations that are genuine social aggregations. They're attracted to each other, but they just aren't highly directed and highly coordinated. Schools, highly directed, highly coordinated, making this beautiful swirling patterns in response to predators. They almost look like super organisms moving through the ocean. If it looks like a giant amoeba made out of fish, it's probably a school. If it's got a bunch of fish just sort of hanging out in their free time, it's probably a shoal. And if it's a lot of individuals just around an environment that they're clearly exploiting some resource and not necessarily paying attention to each other, that's an aggregation. Ta-da. Are there clean lines between these things? The answer is no. How organized is organized enough to make a school? Nobody has any, no one has any idea. And if they did, no one would agree on it. So don't worry about that. And then true cooperation in fish, like trying to assist each other in some way, those are relatively rare and usually revolve around some sort of central resource that has caused members of that species to evolve reduced aggressiveness and higher tolerance of conspecifics because they're stuck with them for long enough that you might as well make use of it through evolutionary time, beginning cooperation. But the evolutionary precursor to that is basically a forced aggregation, usually around a limited resource that becomes 100% saturated in the environment. So you're going to be around conspecifics no matter what. So you might as well cooperate. All right, aggregations could be for foraging, right? I'm in the same area as you because this is the only place that we can find reliable amounts of food. It could be for mating. I'm hanging out with other members of my species because we're all trying to get some boy to copulate with us. Or gal, I suppose, hypothetically. Or, in the case of a lot of these fish, they're sequential hermaphrodites. So I'm a boy but might turn into a girl. I'm a girl that might turn into a boy. I'm some sort of interstitial thing. So there's the notion of binary sexes, although it's highly contentious in humans for a variety of reasons, in fish that becomes really, really complicated because there are lots of sequential hermaphrodites. There are a small number of cases of simultaneous hermaphrodites, but again, but they still aggregate together to mate. God help me, so regardless of whether or not they're hermaphroditic. All right, so anti-predator. So if they're in the same general vicinity, we might aggregate together because this is the rock that is available to hide from that squirrelfish predator. And I don't like you at all. In fact, I want to be wedged down the deepest crevice in this rock so that I'm the least likely individual to get eaten by that squirrelfish as it comes by, that evil, scary predator. We're next to each other, you and I, stuck in this crevice together, along with 5 of our least favorite friends, but we don't love each other. We would love for the other ones to be gone, or to just be a little bit closer to the opening to this crevice so they get eaten and not us. But, we're aggregated. This is our shared physical refuge. It can also be a refuge to abiotic environments. So we all hang out in the kelp because we're sheltered from waves. We all hang out in the kelp because we can't be seen by predators. We all hang out in the kelp for whatever reason. It's dark. It produces high oxygen environment. We don't really like each other, but we just tolerate each other because this is the only place that we can be and get the things that we need to succeed and flourish. Shoals, hooray for shoals, intermediate level. So now we actually interact with each other and we want to be near each other, but we're not coordinating all of our movement. We're not all moving in the same direction as one giant social superorganism amoeba, but we are in one general vicinity because we actually get something out of this. So oftentimes it's just that there are many eyes in these shoals that increase the odds that we'll see a predator before it gets close enough to us to be lethal. It could be a dilution effect. I'm going to hang out with you guys because if I hang out with you guys, the odds are I'm not going to be the one that gets killed. First, if I'm by myself and a predator finds me, I'm the one that's going to get killed if anyone gets killed. Social information, that's not totally independent from the first description. You acquire information about the predator environment when the individual next to you runs, or in the case of fish, swims away. If all of your friends are swimming away, even if you haven't seen the predator, you've acquired social information that the jig is up, something's coming nearby, and you better run too. Swim away, run, figurative sense. Patch discovery, if one of your social group mates are out flicking around at something that you can't see in the water, but they're moving real feverishly, odds are something's interesting over there, like food. Like maybe there's feces from a larger fish, or a banana that some Tahitian tourist from France has dropped into the water. And now you get to all have shreds of banana because some incompetent French person dropped it in the water. Or intentionally, but normally they drop it on accident from a jet ski on their honeymoon. Anyway, great news for us when we're in this shoal, and I can recognize that banana has fallen to the water because you're losing your mind. Even if I never saw that banana, the fact that there's a bunch of my little shoal mates losing their mind increases the odds that I'm going to see that banana and I'm going to run over and try to eat it too. We can all exploit these French tourists together. Okay, so shoals are oftentimes multi-species in biodiverse regions like reefs, where likely to be the only fish hanging out together. And a lot of these benefits, like many eyes and patch discovery, we can get those benefits out of interacting with individuals that are not the same species as us. And that's great because we probably compete with these other species less. They're unlikely to steal your gal or your guy because they can't mate with them. They're less likely to have 100% overlap with the kinds of refuge they need and the kind of food that they consume, et cetera, et cetera. So you can get a lot of the benefits of being in a group by being in a mixed species shoal without all of the intense competition, or at least you can have reduced competition. We may all want this banana, but I might normally eat zooplankton and you eat some sort of photoplankton, or you eat little microalgae off of some turf on some coral, whereas I eat zooplankton, but we both like this banana because it's free food, and obviously they didn't need to have it any longer because they dropped it. They being, in this case, the jet skier. Okay, so single species or multi-species, and they can be a mixed species group. Check. Probably should have heard about that during the bird lecture, but if you don't know, birds do this too. Mixed species flocks. All right, schools are usually highly integrated single species groups that use the homogenization of coloration and body size to basically perplex the predator and share information with each other that enables faster responses, more complete responses, and greater difficulty in the predator tracking individual members of our group, because we actually are a dazzling panmictic superorganism, at least by their perceptual capabilities, scientists think. So there's typically anti-predator, evading predators. They can be migratory. We can all move together in a giant school because we're directing ourselves towards some natal fishing area or spawning area. But normally we do this not just to acquire information, but also to have anti-predator benefits while we're moving to our final destination, which is where we're migrating to. So migration usually has the added benefit of anti-predator benefits during movement, in addition to having something like additional social information about location of resources and stopover areas, et cetera, on our longer migratory route. And so schools are highly directional, like I said before, so they oftentimes look like superorganisms or like murmurations in bird flocks, things like that. Sorry about that watermark here. That was not a conspicuous watermark when I robbed this figure from online. Those are convict tangs, which are super cool. They're marauding giant schools of tangs that wander around the Indo-Pacific. The neat thing about tangs, I don't know if you ever noticed this about tangs, but Dory has a weapon. Most tangs have modified what do they call them? Scales. I'm not multilingual. If I can't find the word, I'm just not capable of finding the word. Anyway, they modified scales flanking their caudal fin that are sharpened and oriented forward so they can flick their tail back and forth if a predator gets near them or a fisherman tries to hold them, then slice up their hand. So tangs are oftentimes called surgeon fish. Surgeon as in, i.e. a scalpel that you can use to slice up your enemy. Haha, right there you are. So Dory has a weapon, heads up, she's packing. And so are these convict tangs. And they're convicted. They're not convicted of anything, they just have stripes. In Canada, do convicts wear stripes? I think they don't even wear stripes in the United States any longer. I think now they just wear orange. Anyway, so fish, they regularly are attracted to conspecifics in these shoals and schools. They can just, if you put them in a Y maze like this, and you have one that's occupied by a member of their species, another that allows them to sit by themselves and allow them to make a choice, they regularly prefer to go to the same spot as a conspecific, a fellow member of their species. Or if it's not a member of their species, they're oftentimes attracted to members of closely related species as well. So you can use a member of your species or a related species to basically infer that the environment is good enough that it hasn't killed that individual so far, so you might as well go over there. So you can use them as a proxy, like a litmus paper test, like that place over there is good enough for them. There must be something over there that's good enough, or food or mates or whatever, at least safe. So I'm going to just use their presence as an overall macro indicator that I can survive and flourish there too. Lots of animals do this. Many animals all over planet Earth do this. Use conspecifics or closely related heterospecifics as indicators of environmental quality and move towards it. If nobody's there, maybe they figured something out that you didn't, and it's not hospitable over there, or the last individual that went over there, went down that road, died. All right, more elaborate benefits can happen as well. So once you're together in a group, you oftentimes have these many eyes benefits, these dilution benefits. They don't require highly sophisticated adaptations to acquire those benefits. You just have to be in a group. So oftentimes you're attracted to a conspecific for one reason, and then get all these added benefits numerically and in terms of sensory capacities automatically. Just added value of interacting with those other members of your species or closely related species. So quite common. All right. If you have a choice, now those two different arms there have two different conspecifics. Now you can be more discerning. It's not just do I go towards a conspecific or not, but now we can evaluate the specific kinds of things that shoaling species tend to look for on average in shoal members, as members of their shoal. They prefer to join the same species as than closely related species. So if you have a choice, go to the one that has related species as you, because they probably have more needs in common, a closer niche match to your own. So their presence is a stronger indicator that that environment will fit you, for you and work for you than a closely related species that might have fewer elements of its niche in common. Oftentimes, fish prefer to interact with kin over non-kin. Who knows why that is, but probably indirect fitness benefits are at least a benefit of it, if not a driver of such behavior. Individuals tend to prefer members of their species that are of comparable size and color. So species that have a highly variable color, individuals tend to want to shoal with fellow members of their same morphotype, the same color and same body size, which adds that idea that certain kinds of shoal homogeneity or school homogeneity helps to dazzle predators or decrease the odds that any one of us can be picked out individually because of our oddity, which I mentioned oddity effects before, but hey, now it's back again. All right. They may want to interact with experienced individuals. So in some cases, especially if there are migratory shoals or the environment is highly heterogeneous, interacting with experienced individuals can be a better indicator that the environment is of high quality. More experienced individuals might know something you don't. So interacting with them means that you might get more reliable social information. And then sometimes individuals will aggregate with more attractive individuals of their species than less attractive individuals. And that's usually female fish that are attracted to more attractive female fish than themselves after they've already been inseminated. So after these female fish have already been inseminated, like in guppies, and they don't need to be inseminated by males any longer, they'll go try to hang out with their most attractive female guppy friends, because that way if a male comes by to harass them, it's less likely that they're individually going to be harassed. They're more likely to be spared while that wanting male harasses her more attractive social partners around her in her shoal. So basically by hanging out with other pretty fish, you can be ignored by harassing males. We know this happens in guppies. We know this happens in some postilids, and it probably happens elsewhere in the animal world, but like, choose your friends wisely. You want to look attractive? Hang around with ugly guppy female fishes. You want to look kind of dumpy because you want to be left alone? Go hang out with beautiful guppy female fishes. Males, it's not clear that males have this level of social sophistication. They want to go where more females are and where virgin females are, but more elaborate strategies than that appear to evade many species of males of many species. Man, I wish you guys were my students. I'd have so many stories. Anyways, so higher levels of sociality. I mean, I'm glad you're my students. Higher levels of sociality where they have true cooperation is relatively rare, but not that uncommon. And normally it's driven by the fact that they adhere to some element of their environment that is rare and basically 100% saturated. So you're gonna have to be around each other anyway. So you might as well do something nice for each other. Cooperative breeders, like the cooperative breeding cichlids that Sigao Balshine interacts with, usually they're assisting a dominant pair of individuals in reproduction, and they actually help. They excavate the nest, they chase off predators, they warn members of their group, sometimes they tend to eggs, so they engage in relatively sophisticated levels of helping behavior that's very overt, it's obvious, right? Byproduct mutualisms, like our anemone fish and clownfish, or like these Dacilus, these little striped fish here, they all adhere to these shared members of their environment, like these coral heads or these anemones, but they don't really try to assist each other by like taking care of each other's babies or excavating for each other. They only help each other through indirect mechanisms like via many eyes, like a predator comes by and everyone's just moving away, so you swim into the anemone as well because clearly there's something dangerous around, or we all swim into the coral head together because we know something is dangerous around, whereas cooperative breeders tend to assist each other in more overt mechanisms. Those cichlids inhabit piles of rocks, which provide anti-predator benefits and also abiotic benefits to those eggs. And all the suitable piles of rocks in the environment are basically occupied. So the best thing that a helper can do is basically just stick around in one of these groups and assist for a little while until a better option to become a breeder comes along. Byproduct mutualism, all the coral heads are occupied, all of the anemones are occupied in the environment. So you recruit to a coral head or you recruit to an anemone head, and you just live with the other individuals that are there, and you just tolerate them basically, and hope one day that you can ascend the ranks and reproduce. So cooperative breeders, why do helpers stay there? Helpers can scrounge some mating opportunities. They can steal some reproductive opportunities from the breeding pair. They may, some people think that helpers pay to stay, i.e. they're only cooperating with the local breeding individuals so that they're not chased off, because if they're not in these piles of rocks, maybe they're more likely to get killed. So they have to pay to stay inside of the territory of these breeders. Notably, in these cooperative breeders, members of that group tend to be at least somewhat related to each other. So there's indirect fitness benefits for helping the breeding pair, at least to some degree. And then if they die, if those members of if the breeding pair dies, a member of them dies, there's a chance that you can inherit that position quickly, a breeding position, if you're right there next to them, rather than trying to find these mating position opportunities in a very broad market. Byproduct mutualisms. Byproduct mutualisms typically have a pelagic larval phase. So in lakes like the African Rift Lakes, where cooperative breeding cichlids live, the young don't disperse that broadly. In the marine environment, tiny little larval fish can live for weeks or months just floating around as tiny little zooplankton in the water before they metamorphose into a teeny tiny little fish. And because they have this pelagic larval phase, many reef fish, these reef fish groups, are not closely related because those fish could have come from miles away or hundreds of miles away in some special instances. And no surprise, the longer that larvae of that species remain in the water column in this tiny little like larval phase, the greater dispersal distance those young can have across the environment. Now, for a long time, we thought that meant that if you're going to be in the water column in the ocean for weeks or months, then it must mean that they go all over the place and there's no genetic structure at all, right? The individuals next to you in your group should be completely unrelated to you, or very nearly so, because the larvae live for months in the water column before they metamorphose, and the ocean is vast and there's storms and blah, 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 blah. It should mix everything up in a giant slurry milkshake. Not true. The ocean is basically a series of rivers and specialty currents and different portions of the ocean, whether or not it's on the surface or along the benthos, are reliably moving in various directions, different times of years based on the weather, et cetera, et cetera. So even though teeny tiny larval fish can't like before they metamorphose, they can't swim against the current, but they can manipulate their buoyancy pretty effectively. So they can decide where in the water column they should be based on the time of year, whether it's storming or not, where the tides are moving, et cetera, et cetera. So even though these tiny little zooplankton can't reliably swim anywhere, they're plankton, they're still able oftentimes to return right back to their habitat of origin, sometimes within just a few meters. So we're now learning, because of genetic mechanisms, that although these fish enter this larval phase, basically tiny little like pollen seeds, like flying or swimming over plankton seeds floating around in the pelagic environment, when they're ready to metamorphose, they can manipulate their buoyancy, determine where in this highway of moving waters in the ocean, which is not pannictic, not a giant milkshake, they can reliably come back to their site of origin, or very close to their site of origin if they would like. Quite neat. So they basically have like a little hot air balloon that they can rise and fall inside of the water column and recruit right back to their natal environment if they should like. So that's neato. It's not perfect, but it's more reliable than you would ever imagine given the fact they can't swim against the current. And then they're out there for months sometimes many months. So because the groups tend to be composed of only loose kin or no significant kinship, usually, although, you know, like still they might show up at the anemone next door instead of their anemone of their parents, or a couple of bomies of coral heads down, they might recruit to that instead of their natal abami, their natal coral head. The group within this anemone itself tends to be composed of only loose kin or not kin at all, which means they're not really directly helping each other all that much. They're basically just waiting for the individuals in front of them in line to die. So they don't engage in excavating. They don't engage in care of the young of the breeders in that anemone or in that coral head. But they might cue in on each other if there's an attack of a predator and all swim in together. That's just, no one's intentionally doing that. It's just every individual that has a predator coming near wants to run like hell. And so everybody else cues in on the fact that everybody else was running like hell and they run too. Nobody meant to cue in Bob over there, but Bob saw us running as an ugly byproduct of me running like hell. Bob's going to figure out that the environment is dangerous. I'd much prefer for Bob to die out there, right? Because he's competition. Or God forbid, Bob could be the reproductive. I definitely want him to die then, but because I've run away, he gets that social information as a byproduct of me acting in my own interest. Same thing with helping the host. We're all peeing basically all the time on our anemone or on our coral, and they're usually nitrogen limited, the anemones or corals, and so they grow faster and stronger because we're all peeing on the same coral head or anemone. No one is intentionally peeing on this shared resource because it's helping the other individuals around. We all just have to pee, and so when we pee on this anemone or we pee on this coral, it's going to grow faster, and that helps everyone involved. We grow faster, all of us, because our host plant, which is not really a plant, it's actually an animal, an idarian, grows faster and larger. So we can all grow faster because of that. So, but are we doing that intentionally? Nope. Nope. It's the safest place to pee. Swimming out into the middle of the water column and urinating means you're more likely to get picked off by a predatory fish, because if we're adhered to this anemone or we're adhered to this coral head, odds are we're also not such great swimmers any longer. We lost that capacity a long time ago, and so we got to stick close to home. All right, that was longer than I thought it would be, but I hope you enjoyed it, and I'll see you guys tomorrow. I'm sorry this thing went up late. I really do apologize, but I hope you guys enjoy it. Take it easy. Bye.